So something you'll want to have a very good handle on before going into calculus are just the basic shapes of graphs. Kind of knowing the basic form of a graph before any transformations take place. And even though I'm making this video in terms of just pre-calculus 1 review, but with these I would throw in knowing the basic shapes of sine and cosine. We could even actually throw tangent in there. I would say knowing the structure of those three graphs really well going into calculus will be very helpful. Because a lot of what you'll do is with the graphs and evaluating rate of change at certain points, slope, things like that. And if you have a handle on these graphs, it can help so much in terms of the work that you have to do just for calculus. Okay, so going through these, this one that looks like a V that's sitting at 0, this is our function, the absolute value function. So the basic structure for that graph is just the absolute value of x. That's why all of our outputs are positive. So if we plug in -2, we're getting out +2. And it's just a sharp change from positive to negative. This is our parabola. So this is our function x squared. And this function right here is our cubic function. So this is x cubed. And I think of this like x squared is going to make everything positive. So 1, 1, -1, 1, +2, 4, -2, 4 as well if we plug in -2 there. But when you're cubing, you can have negative outputs. So like 2, +8, -2 would give us -8. Alright, this one here is our square root function. So you can see if we plug in 4, we're getting an output of 2. This is just the square root of x. And over here, this would be our cube root of x. This is our rational function. So this is our 1 over x, and as you can see here we have a vertical asymptote at 0, and that's because we cannot plug in x equals 0, since we cannot divide by 0. Same thing happens here, but what you'll notice is that all of our outputs are positive here, and that's coming from a 1 over x squared. So we're squaring all of our inputs, but we can't plug in 0. Alright, right here, this is our function e to the x. So this is our exponential function, and maybe even just having a review of exponential functions can be helpful for how to graph those. But this is with base e, and how I can tell that is, so there were 2 pieces to our exponential functions. We have this number out front, which in this case is just 1, which I'm seeing right there at 0, 1. If this was 0, 5, I would see a 5 right there. So at 0, that tells you the number that's out front multiplying. But then what I did is looking at x equals 1, looking for the coordinate, that's at about 2.7. 2.78 even, which is our value for e. So that helps kind of set up the base of the exponential part. Alright, and then right here what we can see is we have 1, 0, and then if I go to +1 here, there's that same 2.78, so this is like about 2.781. So this is actually the inverse function of our e to the x, which is our logarithm. So this would be our logarithm base e, which is the natural log of our function x. So these right here are inverse functions. And that's where the logarithms come from, is that we need this inverse form of exponential functions. So that's where we start using logarithms. Alright, so just an overview of our graph transformations, which we did quite a bit of that in our class with the trigonometric equations and making their graphs. So we have the up or down, left or right, vertical stretch or compression rather, horizontal stretch or compression, reflect over x-axis, reflect over y-axis. So there's all of our pieces. So let's just go through an example with this. So what I can notice with this is that my basic function is the square root of x. So what I could do is I could get a graph going, just kind of sketching lightly on the paper of my square root function. So I'd 0, 0, I'd have 1, 1, I'd have 4, 2, I would have 9, 3 if I could see that far. Let's see, 3, 6, 8. I'm just going to kind of sketch it off to the side here because that can be helpful. So what I have there is our square root of x function. But what we have are all sorts of transformations that are taking place in there. So what I'm going to do is rearrange this because I need to factor out that 4 underneath, because this value, or rather, especially since there's going to be a horizontal shift, there shouldn't be anything multiplying with x when we evaluate that value for c right there. So I'm going to factor out a 4, which will leave us with x minus 2. So now what I can see here are 3 things I need to do. The negative out front is telling me to flip over the x-axis. In fact, I could go ahead and take care of that right now. So 0, 0 is going to stay the same, but then 1, 1 will be down here, and 4, 2 down here. And I could just go ahead and look at that 3 down there. So this right here is our flip. And if it helps, I can go ahead and erase everything up there. So I took care of one part of the transformation. Then we have that 4 multiplying. So that's going to be a horizontal compression, because with the horizontal, kind of works flip of how you think it would. So this would be a horizontal compression by, and then you use 1 over the number. So this is by 1/4. So what I want to do is thinking horizontally, all distances, I want to shrink them by 1/4. So what that's going to look like is, okay, 0, 0 is going to stay the same. That's not moving anywhere. This horizontal distance of 1 right here, I'm taking 1/4 of that. This distance of 4 right here, I'm taking 1/4 of that. And then I'll go ahead and think about that distance of 9. And I'm going to take 1/4 of that. So let's see, 9/4. That should be 2 and 1/4. So 1, 2, and 4. And then I can just leave it at that. So I can get rid of those red dots because now I have this new transformation. We could probably get even more points out, but that's a good foundation for what we're doing. Alright, one more transformation with the x minus 2. So that's going to be a horizontal shift. And since it's subtraction, that will be to the right by 2. So my final graph, I'm going to pick up those points that I just graphed and move them to the right 2 units. 1, 2, 1, 2, 1, 2. And that'll be the end of the graph. And then with these, when you have a graphing calculator available, be sure to go and check it. Graph it, make sure you are landing up right there. But that's how we would find the solution, just using the transformations. So with that, just be comfortable with those basic functions before going on to calculus, and then being able to graph them with transformations, or at least just getting a sketch going with transformations. Being able to visualize where it's landing on a grid is very helpful.